Hello students and good morning. So now I am doing class for class 12. The topic is the same topic that we were doing in the last online class, that is second order derivative. Okay. So in the last online class also we did some problems from 5 marks section in second order derivative. So today we will do more problems on this section, that is 5 marks. That is the chapter second order derivative. Okay. So same exercise 4, 5 marks, page number 322 from the book Higher Mathematics for class 12 by Sailendra. So let's start from question number 6. So in the last class we did question number 5. Now let's start this question number 6. If x is equal to capital A e to the power minus kt divided by 2 cos pt plus epsilon, this is your epsilon. Okay, this is known as epsilon. This is known as what? Epsilon. You have to show that d2x by dt square plus k dx by dt plus n square x is equal to 0, where n square is equal to p square plus 1/4 k square. So from this given you have to prove the required relation where n square is equal to p square plus 1/4 k square. So in this case, before you do the problem, you should know which are constants and which are variables. So which are the variables out here? How do we know that which are the variables here? Since you have to get dx by dt and d2x by dt square. So this dx by dt, x and t will be the variable and all other terms will be constant. यसमा तिमीको x र t मात्रै variable हुन्छ, तर अरु सबै terms चाहिँ के हुन्छ? Constant हुन्छ. That means only x and t are the variables here. All these things, that is capital A, K, epsilon, P are all constant except x and t. So here x and t are the variables and all other terms are constant in this case. So you have to prove this relation where n square is equal to p square plus 1/4 k square. Okay. So you know epsilon here, this is known as what? Epsilon. So let us prove the required relation. So first of all, you have to get dx by dt. Okay. So here given is x is equal to capital A e to the power minus kt by 2 cos, this is your pt plus epsilon. Okay. Now you have to find dx by dt. Here x and t are the variables, so you have to find out first dx by dt. So differentiating both the sides with respect to t. So this is your dx by dt is equal to, now here which are the variables? Wherever there is t, these are the variables. That is e to the power minus kt by 2 is the variable, because here this is t. This e to the power minus kt by 2 is the variable. Again t is here, that is cos pt plus epsilon is the variable. Only here constant is capital A. You have to keep it as it is, right? So in this case you have to use UV rule. So now capital A is constant, it is kept as it is. What is the differentiation of e to the power minus kt by 2? You know that it is e to the power minus kt by 2 into, again you have to differentiate minus kt by 2. This is in the form e to the power x. E to the power x differentiation of e to the power x. But here it is e to the power minus kt by 2. Which function is taken as x? Minus kt by 2. Again you have to differentiate it with respect to t. That is your minus k by 2. Now this term cos pt plus epsilon is kept as it is. That is cos, this is your pt plus epsilon is kept as it is. Okay. Now plus, which function is taken as it is now? A capital A e to the power minus kt by 2 is kept as it is into, now you have to differentiate cos pt plus epsilon. This is just like your cos x. What is the differentiation of cos x? Minus sin x. So it is minus sine of x, here is pt plus epsilon. Now again you have to differentiate the term which is assumed as x with respect to t. That means what is the differentiation of pt plus epsilon with respect to t? That is p into d by dt of t is p, and for epsilon it is 0. Is that clear? For epsilon, epsilon is constant here. So differentiation of pt is p is taken outside, d by dt of t is 1. That is only p is there, and plus epsilon. For epsilon, the differentiation is always 0. Is that clear now? So let's simplify it further now. Or now this is dx by dt is equal to, now here you can write minus ak by 2. This is constant. Now write down e to the power minus kt by 2 into cos, this is your pt plus epsilon. Is that clear? Then again plus or minus, minus, here this p is constant, it is taken outside, that is p into capital A e to the power minus kt by 2 into sine of, this is pt plus epsilon. So I think you have understood it. Now instead of this capital A e to the power minus kt by 2 cos pt plus epsilon, you can write x, isn't it? What is the value for capital A e to the power minus kt by 2 cos pt plus epsilon? It is x, isn't it? So instead of capital A e to the power minus kt by 2 cos pt plus epsilon, you can write x here. So, or this is your dx by dt is equal to minus k by 2. This minus k by 2 is kept as it is. You write down that one. So now instead of capital A e to the power minus kt by 2 cos pt plus epsilon, you can write it as x. This is your x. Is that clear? So then this function is kept as it is. That is minus p capital A e to the power minus kt by 2 and this sine pt plus epsilon. So I think you have understood it. So we got this result now. Okay. Now again you have to differentiate this term in order to prove this required result. But before that, you can take the term containing x on the left hand side. That is minus kx by 2. Take it to the left hand side. Okay. So now write down next, or dx by dt plus k by 2 into x, which is equal to minus pa e to the power minus kt by 2 into sine pt plus epsilon. Okay, this minus kx by 2 is taken to the left hand side. Okay, so this is your number 1. So I think you have understood it. Okay, so next what will you do? So why is it marked as number 1? Because we may use the value of p capital A e to the power minus kt by 2 sine pt plus epsilon as dx by dt plus kx by 2. Now again you have to differentiate it with respect to t. So differentiating both the sides with respect to t. So therefore d2x by dt square plus k by 2 into dx by dt is equal to, now again you have to use uv rule here. Minus pa is constant, but e to the power minus kt by 2 sine pt plus epsilon, they are the variables, so you have to use u by v rule in this case. Okay, so now minus pa, that is constant, it is kept as it is. Now differentiate e to the power minus kt by 2 with respect to t. What is it? E to the power minus kt by 2 into minus k by 2. You know that. How did we get minus k by 2, right? Then sine pt plus epsilon is kept as it is. Right? Then next, since there is minus sign here, so minus into plus will be minus. You know that, isn't it? So here in this case, तर यो बीचमा चाहिँ uv रुल गर्दा प्लस हुन्छ, तर यो माइनस साइनले गर्दा माइनस इन्टु प्लस के भयो माइनस, राइट? So now which functions are kept as it is? P capital A e to the power minus k by 2 is kept as it is. Now differentiate sine of pt plus epsilon. What is it? So it is in the form cos x. What is the difference? So it is in the form not cos x, but it is sin x. What is the differentiation of sin x? Cos x. So it is cos pt plus epsilon. Again differentiate pt plus epsilon with respect to t, which is p. So I think you have understood it. Okay. So now in the next step, we can write here, left hand side write down d2x by dt squared plus k by 2 into dx by dt is equal to minus into minus. This one is plus, so is equal to plus. Plus sign usually we don't write it. Okay. So now here you can write minus k by 2. Write down minus k by 2. Okay. Minus k by 2 is written out here. So within bracket, this minus k by 2 is written here. So within bracket we have minus pa, right? Minus pa. Then you write e to the power minus kt by 2. E to the power minus kt by 2. Then write down sine pt plus epsilon. Bracket closed. Right? So why is it written within bracket? That is minus pa e to the power minus kt by 2 sin pt plus epsilon. Because from 1 we can put the value for minus pa e to the power minus kt by 2 sin pt plus epsilon. That is, we can write down this value as what? Its value is actually dx by dt plus k by 2 into x. So we can write down, instead of minus pa e to the power minus kt by 2 sin pt plus epsilon, we can write it from 1, that is dx by dt plus kx by 2. So that's why it is written within bracket. Okay. So minus here, this p into p is p square, right? Then write down capital A e to the power minus kt by 2 cos pt plus epsilon. So I think you have understood it. So now you can simplify it further now. Or d2x by dt square plus k by 2 into dx by dt is equal to minus k by 2 into, now what is the value for minus pa e to the power minus kt by 2 sin pt plus epsilon from number 1? Its value is dx by dt plus kx by 2. It is within bracket you write dx by dt, then what do we write? Plus kx by 2. Plus kx by 2, bracket closed. Then what do we write here? So here you can write minus p square into, instead of that expression, capital A e to the power minus kt by 2 cos of pt plus epsilon. What can you write it for? You can write it x for it. So capital A e to the power minus kt by 2 cos pt plus epsilon, instead of this expression you can write x. So here we can write x out here. So I think you have understood it. So you can copy it. So in the next step we can simplify it further, right? So now let's simplify it further. So now, or this is your d2x by dt square plus k by 2 into dx by dt is equal to, now multiply them, minus k by 2 into dx by dt, then minus into plus, minus, right? K by 2 into k by 2 is k square by 4 into x minus p square x. Minus p square x. Is that clear to all of you? So next, what will you do? Take all the terms to the left hand side to make right hand side 0, right? Since we have to prove here on the right hand side 0. So take all the terms to the left hand side. So or it is d2x by dt square plus k by 2 into dx by dt plus k by 2 into dx by dt. This one is plus k square by 4 into x plus p square x, which is equal to 0. So I think you have understood it. So now here you can simplify it further, or d2x by dt square plus. So if you add them, these are two similar terms. You can add these two terms. That is k by 2 into dx by dt plus k by 2 into dx by dt. What is it? 2k by 2 into dx by dt. Same terms are there. If you add them, you will get 2 twice into k by 2 into dx by dt. That means 2 gets cancelled here. So it is k into dx by dt plus. So in this case, what is common? X is common here. So within bracket we have k square by 4 plus p square into x, which is equal to 0. So I think you have understood it. Okay. Now by question, what can you write for k square by 4 plus p square? We can write any square. Instead of k square by 4 plus p square, we can write p square plus 1/4 k square is equal to any square. So instead of this expression, we can write any square. Okay. So, or this is your d2x by dt square plus k into dx by dt plus, next, what is this p square plus k square over 4, which is any square, right? So this is your any square x, which is equal to 0. So it is proved, isn't it? So d2x by dt square plus k dx by dt plus any square x is equal to 0. So it is proved. So this question is also very, very important. So we can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 7. If 2x is equal to y to the power 1 by 5 plus y to the power minus 1 by 5, you have to prove that a relation is to be proved. What is the relation here? Within bracket x square minus 1 bracket close y2 plus x y1 is equal to 25y. That means you have to find out the relation in terms of y2 and y1. You know that y2 is d2y by dx square and y1 is dy by dx. So from the given relation, you have to prove this relation. Okay. So now in the given question, x is expressed in terms of y. X is expressed in terms of y. So in order to get dy by dx and d2y by dx square, you have to express y in terms of x. Bujhdacha? So here in the given equation, x is expressed in terms of y. But in this case, you have to express y in terms of x to prove this required relation. So यो जुन चाहिँ हामीलाई रिलेसन प्रुभ गर्नु दिएको छ in terms of y1 and y2, त पहिला हामीले के गर्नुपर्छ, यो जुन चाहिँ गिवन इक्वेसन छ, यो गिवन इक्वेसनमा x is expressed in terms of y. तर हामीले के निकाल्नु पर्छ, y को भ्यालु निकाल्नु पर्छ in terms of x. लेफ्ट साइडमा चाहिँ y हुनु पर्यो, राइट साइडमा चाहिँ एक्सप्रेसन अफ x हुनु पर्छ. That is function of x हुनु पर्छ. You have to express y as a function of x. बुझ्यो? त यहाँ चाहिँ x as a function of y is given, but you have to express y as a function of x. That is, you have to find out the inverse function. Is that clear? You have to find out what? You have to find out the inverse function. That is, you have to express y in terms of x in order to prove this relation. Is that clear? So now let's do it. So now here given is 2x is equal to y to the power 1 by 5 plus y to the power minus 1 by 5. Okay. So let us simplify this right hand side, or 2x is equal to y to the power 1 by 5 plus, so how will you simplify y to the power minus 1 by 5? So it can be taken to the denominator to make it positive. So 1 upon y to the power 1 upon 5. Okay. So now here, or 2x is equal to, what's the LCM here now? What's the LCM? It is y to the power 1 by 5 is the LCM. What is the numerator here? So y to the power 1 by 5 whole square plus 1. So you know this simplification, isn't it? So below 2x, there is 1. Now you can do cross multiplication. So cross multiply by 1 here, it is y to the power 1 by 5 whole square plus 1 is equal to 2x y to the power 1 by 5. So I think you have understood it. Okay, अब हामी के गर्छौं, let us take this 2xy to the power 1 by 5 to the left hand side. Okay, to make right hand side 0. हामी right hand side चाहिँ 0 बनाउँछौं यहाँ. So or now this is y to the power 1 by 5 whole square, then minus 2x y to the power 1 by 5, then there is plus 1, isn't it? So this 2x y to the power 1 by 5 is taken to the left hand side to make it negative. That is minus 2x y to the power 1 by 5, then plus 1 is equal to 0. Now this is a quadratic equation. You know that quadratic equation, isn't it? So this is a quadratic equation in terms of y to the power 1 by 5. So you can compare it with ax square plus bx plus c is equal to 0. Okay, so compare these two quadratic equation, right? So what is the value for x here? It is y to the power 1 by 5. It is y to the power 1 by 5. That is, instead of x here, what is there? Y to the power 1 by 5. But what is the value for a in this case? It is 1. It's already 1 cha. A ko value 1 भयो. B ko value कति भयो? minus 2x. अनि c ko value कति भयो? 1 भइगयो. So I think you have understood it. So now you know Sridhar Acharyya's formula, isn't it? So we know that. So this is the formula now. The formula is x is equal to minus b plus minus root over b square minus 4ac whole divided by 2a. So this is Sridhar Acharyya's formula for this quadratic equation. So we have written here the formula from Sridhar Acharyya's formula, right? So instead of x here, what is there? It is y to the power 1 by 5, right? So which is equal to, यो x को सट्टामा यहाँ y to the power 1 by 5 छ. A भने b भनेको कति हो त? b भनेको minus 2x हो. You can compare these two quadratic equation. A is equal to 1, b is equal to minus 2x, and c is equal to 1. So let us put the values out here. So it is minus sign लेख्नु, यो minus b भनेको कति हो? minus 2x plus minus root over, what is b? Whole square. What is b in this case? minus 2x whole square minus 4 into, what is a? A भनेको 1 हो, अनि c भनेको पनि 1 हो, whole divided by, what is 2a? 2 into, what is a here? A is 1. Is that clear to all of you? So I think you have understood it. Okay, so now y to the power 1 by 5 is equal to minus 2x plus minus root over, oh sorry, this one is not minus 2x, this is minus sign, because in the formula there is minus sign. What is the value for b in this case? minus 2x. This is your minus 2x, right? So यहाँ मैले mistake गरेछु छु, b is equal to 2x हालेछु, that is wrong. तर b भनेको कति हो? minus 2x, बुझ्दैछ? So this is minus into minus is plus. So usually we don't write plus sign here. तर यहाँ हामीले ठिकै हालेछौँ, b is equal to minus 2x, that is correct. Okay, so plus minus, what is minus 2x whole square? It is 4x square minus 4 whole divided by 2. So I think you have understood it. Okay, so or this is your y to the power 1 by 5 is equal to, this is 2x plus minus, now you can simplify expression within square root. So what is common here? 4 is common. So within square root 4 is common. What is square root of 4? It is 2. 2 root over x square minus 1. This whole divided by 2. So I think you have understood it. So what is common in the numerator? 2 is common in the numerator, and this 2 will be cancelled from both the numerator and the denominator, right? So let us write here. So what is y to the power 1 by 5? Y to the power 1 by 5 is equal to, this will be x plus minus root over x square minus 1. Is that clear? So in this case, in the numerator 2 is taken common, and 2 from both the numerator and the denominator will be cancelled, and we got this relation. Okay, now let us get the value for y. So what is the value for y in this case? So y is equal to, if it is y to the power 1 by 5 is there, y to the power 1 by 5 is there, what is the value for y? It is just like cross multiplication, but you have to do the cross multiplication in the power, right? So it becomes x plus minus root over x square minus 1 whole to the power 5. Is that clear? So we have expressed y in terms of x. Sometimes you may be asked to find out the value of y in terms of x from the relation 2x is equal to y to the power 1 by 5 plus y to the power minus 1 by 5. So this is the method to find out y in terms of x when x in terms of y is given. Is that clear to all of you? So now let us differentiate it to prove the relation. Okay? त यसलाई हामी के गर्छौं? Differentiation गर्छौं. So differentiating both the sides with respect to x, right? So differentiating both the sides with respect to x. Now let's differentiate both the sides. So this will be dy by dx is equal to, now it is just like your x to the power 5, isn't it? Now within whole to the power 5 there is x plus minus root over x square minus 1. This is assumed as x. So what is the differentiation of x to the power 5? 5x to the power 4. But here it is 5 within bracket x plus minus root over x square minus 1 whole to the power 4 into, again you have to differentiate the term which is assumed as x. हामी फेरि त्यो x को टर्मलाई डिफरेन्शिएट गर्नुपर्छ जसलाई चाहिँ हामीले x सम्झेको थियौं. केलाई x सम्झेको थियौं? x प्लस माइनस रुट ओभर x स्क्वायर माइनस 1 लाई. त यसलाई हामी फेरि डिफरेन्शिएट गर्नु पर्यो. So within third bracket, what is the differentiation of x? 1 plus minus remains as it is. Now in the next step, what is the differentiation of this square root? Square root of x. Let us take it as a square root of x. What is the differentiation of square root of x? It is 1 by 2 root over x भनेको कति हो यहाँ? x square minus 1. त फेरि x square minus 1 लाई हामीले x लिँदै छौं, त्यसलाई फेरि डिफरेन्शिएट गर्नु पर्यो. त इन्टु what is dy dx of x square minus 1? It is 2x minus 0. 2x minus 0 भनेको कति हो? 2x. Third bracket is closed. So I think you have understood it. So here 2 gets cancels. 2 gets cancels. So or this is dy by dx is equal to 5x plus minus root over x square minus 1 whole to the power 4, right? So into within third bracket, what's the LCM here? It is x square minus 1 is the LCM. So numerator becomes root over x square minus 1 into 1. That is your root over x square minus 1. And this is plus minus, this one is x. So I think you have understood it. Okay. So now let us simplify it further now. Let us simplify it. Now, अब यसलाई हामी फेरि अहिले डिफरेन्शिएट गर्नुपर्छ नै हैन. Before that you have to simplify it. So you have to cross multiply by root over x square minus 1 here. Your dy by dx लाई, this dy by dx should be multiplied by root over x square minus 1. That means we are doing cross multiplication. Or this is your root over x square minus 1 into dy by dx, right? So it is cross multiplied. dy by dx is cross multiplied by root over x square minus 1, which is equal to 5 into x plus minus root over x square minus 1 whole to the power 4 into, and here you can take common here. So how can you take common here? If it is plus sign, यदि यो plus sign भयो भने हामी के गर्छौं हेर्नु. So हेर यसलाई common कसरी निकाल्छ? x square minus 1 plus minus x is there, right? Suppose you write only x, we can have x plus minus root over x square minus 1. You can write it. Is that clear? That is x plus root over x square minus 1. तर यदि minus भन्छ यो root over x square minus 1 minus भयो भने हामी यहाँ minus common निकालेर x लाई अगाडि लेख्छौं. So minus is taken common within bracket x. Is that clear? Minus is taken common within bracket x. Minus into plus is minus root over x square minus 1. Is that clear? यदि यो plus मात्रै छ अरे, suppose it is only plus sign, then we can write here within bracket, you can write x first then plus root over x square minus 1. That is a plus b is equal to b plus a. But if there is minus sign, if you write root over x square minus 1 minus x, then in order to write x first, you take minus common. So within bracket, what do we get? Minus into minus plus x, minus into plus is minus root over x square minus 1. But in this case, both the sign are written here together. So combining these two, what do we get? So you दुईटालाई अब हामी combine गरौँ. Plus minus is taken common. Plus minus is taken common. Within bracket, you can combine this expression again. So what do we get? X, again it is plus minus root over x square minus 1. Is that clear to all of you? त यो कमनहरु निकालेको तिमीले बुझ्यौ होला. हामीले पछाडी यसमा लेख्दा चाहिँ यो दुईटालाई नै हामीले कम्बाइन गर्नुपर्छ. बुझ्नु भएन? So first of all we take plus here, root over x minus 1 plus x. So you can write here x first and root over x minus 1 at the second term here. But in this case there is minus sign, there is another sign also, root over x minus 1 minus x. You take minus common here and within bracket what do we get? Minus into minus plus x. Minus into plus is there. Minus into plus is minus root over x minus 1. So you have to write here combination of both these sign. That is plus minus sign is written out here. And within bracket also combining these two, what do we get? X plus minus root over x square minus 1. I think you have understood it. Okay. So I think you have understood this rough work. You can copy it. Okay. So now let's simplify this right hand side now. Or this is root over x square minus 1 into dy by dx, which is equal to plus minus is written outside or in front of 5. Plus minus 5 is written in front of 5. 5 को अगाडि plus minus लेख्नु. अनि यो दुईटा त similar expression भयो नि त. If you multiply them, powers will be added. If it is x to the power 4 into x, then we can write x to the power 5. Likewise, we can write here x plus minus root over x square minus 1 whole to the power 5. So I think you have understood it. Okay. So in the next step, what will you do? Instead of x plus minus root over x minus 1 whole to the power 5, you can write y, isn't it? So let us write there. Root over x square minus 1 into dy by dx is equal to, this is your plus minus 5. Then what is the value for x plus minus root over x minus 1 to the power 5? It is y. So you can write here y. Is that clear now? So you can copy it. Now in the next step, what will you do? So what will you do in the next step? Remove this square root. That means you have to square both the sides in order to remove square root from the left hand side. Okay. So squaring both the sides. Squaring both the sides. Squaring both the sides. So what do we get squaring both the sides? Therefore, square root will be removed from the left hand side. So it will be x square minus 1 into dy by dx whole square, which is equal to, on the right hand side, what is plus minus 5y whole square? What is it? Plus minus whole square is also plus. Plus whole square is plus. Minus whole square is also plus. So plus sign usually we don't write. What is 5 whole square? It is 25. Then you can write y square. Okay. Now you can easily differentiate it. Okay. And we can prove this required result. So write down. Again differentiating both the sides with respect to x. Again differentiating both the sides with respect to x. Okay. So we can use your UV rule. dy by dx whole square means dy by dx into dy by dx. Okay. So next, x square minus 1 is kept as it is. We have to use UV rule for its differentiation. What is the differentiation of dy by dx whole square? First of all, it is x square form. 2x, that is 2 into dy by dx. Again differentiate the term which is assumed as x. That is, you have to differentiate dy by dx with respect to x, which is d2y by dx square. Okay. Now keeping dy by dx whole square as it is, take the differentiation of x square minus 1. So what is this differentiation? So you have to write down plus sign. What is the differentiation of x square minus 1? It is 2x minus 0, that is 2x into, now dy by dx whole square is kept as it is, right, which is equal to, now differentiate 25y square with respect to x. How much is it? 25 is constant, it is kept as it is, into, what is the differentiation of y square? What is the differentiation of y square here? It is 2y into dy by dx. So I think you have understood it. Okay, differentiation of y square with respect to x is 2y into dy by dx. Now what is common out here? What is common? 2 into dy by dx is taken common. So within second bracket, what do we have? X square minus 1 into d2y by dx square plus 2 is taken common here. Also one of these dy by dx whole square is taken common. I told you that dy by dx whole square means dy by dx into dy by dx, right? So one of these dy by dx is taken common. So here remains x into dy by dx. Second bracket close is equal to 25 into 2y into dy by dx. So as you know that since 2 dy by dx not equal to 0, so you can cancel it. 2 dy by dx gets cancelled out here. So what do we get? So instead of d2 by dx there is y2. Instead of dy by dx there is y1. So you can write here x square minus 1 into, this is your y2, plus x, what is dy by dx? y1, which is equal to, this is your 25y. So we have got the result. Okay, so it is proved. So this question is also very, very important. So you can copy it. So now we'll do the next question. Now we'll do the next question, that is question number 8. If y to the power 4 plus 5xy plus y is equal to 2, find dy by dx and d2y by dx square. You have to find out the values of both dy by dx and d2y by dx square when x is equal to 0 and y is equal to 1. When x is equal to 0, y is equal to 1. So when x is equal to 0, y is equal to 1, you have to get the value for dy by dx. Also, you have to get the value for d2y by dx square when x is equal to 0, y is equal to 1. So now let us differentiate it, okay, with respect to x to get dy by dx first. So here given is y to the power 4 plus 5xy plus y, which is equal to 2. So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what is the differentiation of y to the power 4 with respect to x? First of all, it is 4y cube. Again differentiate y with respect to x, because we are differentiating both the sides with respect to x, right? So plus, for 5xy, for xy you have to use UV rule, okay? So 5x is kept as it is. Take the differentiation of y with respect to x, it is dy by dx, plus now take the differentiation of x with respect to x, which is 1, keeping 5y as it is, plus 5y, plus, then what is the differentiation of y with respect to x? It is dy by dx, which is equal to 0. And the differentiation of this constant 2 with respect to x is always 0. Now, again from this term, first term, second term and last term, what is common? Dy by dx, take it out. Dy by dx is taken common. Within bracket, what do we get? 4y cube plus 5x plus 1. Since you have to get the value for dy by dx, take this term 5y to the right hand side. So which is equal to, this is minus 5y. I think you have understood it. Okay. So, or what is the value for dy by dx now? So dy by dx is equal to minus 5y whole divided by 4y cube plus 5x plus 1. Is that clear to all of you? So let us mark it as number 1. हामी यसलाई केमा गर्छौं? Number 1 मा गर्नेछौं. ठीक छ? त यसलाई हामी फेरि डिफरेन्शिएट गर्छौं अहिले बट बिफोर दैट get the value for dy by dx when x is equal to 0 y is equal to 1. Okay, so now let us put the value here when x is equal to 0 y is equal to 1 यसमा हाल्नु number 1 मा. So therefore dy by dx which is equal to minus 5 into 1 y is 1 here divided by 4y cube 4 into 1 whole cube, right, plus 5 into what is x 0 and plus 1 is there, so it is plus 1. Okay, let us simplify it. Or what is the value for dy by dx now? Dy by dx is equal to minus 5 divided by 1 whole cube is 1. This is 4 ones are 4 plus 0 plus 1 which is equal to minus 5 divided by 5 which is equal to minus 1. So what is the value for dy by dx which is equal to minus 1? So we got the answer, first part. So what is the value for dy by dx which is equal to minus 1 when x is equal to 0 y is equal to 1. Now we have to get the value for d2y by dx square when x is equal to 0 y is equal to 1. So let us differentiate this number 1 again, right? So again from 1 what do we have? We have dy by dx is equal to, this is your minus 5y divided by this is 4y cube plus 5x plus 1. Okay, now let's differentiate it both the sides with respect to x. So now write down, again differentiating both the sides with respect to x. Again differentiating both the sides with respect to x. Okay, now in this case you have to use u by v rule. You know quotient rule or u by v rule for differentiation, right? So for dy by dx it is d2y by dx square which is equal to, now here minus is taken outside. Now within third bracket you have to use u by v rule. Now you know u by v rule, keeping the denominator as it is. Denominator means it is 4y cube then plus 5x plus 1 as it is. Take the differentiation of 5y with respect to x. So it is 5 into dy by dx. Is that clear? Then put minus sign, because in case of u by v rule you have to use minus sign. Now which function is taken as it is? 5y. It is 5y. Is that clear to all of you? Now you have to take the differentiation of the denominator with respect to x, right? So now let us take the differentiation of the denominator with respect to x, keeping the numerator as it is, right? So within bracket, what is the differentiation of y cube? 4 is there. For y cube it is 3y square into dy by dx. So 4 3s are 12y square dy by dx. Is that clear now? Then plus, what is the differentiation of 5x with respect to x? That is your 5. That is your 5 plus what is the differentiation of 1? That is your 0. Bracket is closed. Is that clear? So the differentiation of the denominator with respect to x is, it is 4 3s are 12y square dy by dx plus, for 5x it is only 5 plus 1 it is constant, it is 0. Is that clear? So whole divided by this, whole divided by denominator whole square, that is 4y cube plus 5x plus 1 whole square. Okay, so here this third bracket is closed. So I think you have understood it. So now don't simplify it further to get the value for d2y by dx square, but in this case you can put the given values, that is when x is equal to 0 y is equal to 1, and what was the value for dy by dx? It is minus 1, right? So here you can write when x is equal to 0 y is equal to 1 and dy by dx को value अघि हामी कति निकालेको थियौं? minus 1, right? So let us put these values out here. Okay, so or d2y by dx square, d2y by dx square is equal to minus, within third bracket let us put the value here. within bracket 4 into 1 whole cube, 5 into 0 plus 1, right? 5 into what is dy by dx? dy by dx is minus 1. Minus 5 into what is the value for y? 1. Within bracket 12 into 1 whole square into what is dy by dx? Minus 1. Then it is plus 5. Whole divided by, in the denominator, what do we write? It is 4 into 1 whole cube plus 5 into 0 plus 1. This is your whole square. Third bracket is closed. I think you have understood it. So you can copy it. So you can copy it. So now let's simplify it further. Okay. So you can copy it. This is dy by dx is minus 1, right? This is minus 1. So let us simplify it further. So let us simplify it. Or this is your d2y by dx square, which is equal to minus sign. So now here this is 4, 1 cube is 4 plus 0 plus 1. That is your 5. 5 into 5 into, this is your minus 1. And here this is minus, 5 ones are 5 within bracket. This is minus 12 plus 5. This is plus and minus minus 12 plus 5. So whole divided by within bracket 4 into 1 cube, that is your 4 plus 0 plus 1 whole square. Here third bracket is closed. Okay. Now let us simplify it again. So or this is your d2y by dx square, which is equal to minus sign within third bracket. This is minus 25 minus 5 into, this is your minus 7 divided by 4 plus 1 is 5 whole square is, this is your 25, right? So next, or d2y by dx square, which is equal to minus sign within third bracket minus 25 plus minus into minus plus 7 5s are 35 divided by 25. So we can simplify it further. That is, or d2y by dx square, which is equal to this one will be minus, you minus already. What is 35 minus 25? You have to write down the greater, you have to write down the sign of the greater number. What is minus 25 plus 35? That is plus 10 divided by, this is your 25. So I think you have understood it. Okay. So minus sign is there. So it is minus 25 plus 35, different sign, you have to subtract it, that is 10, and write down the sign of the greater number, that is plus sign. So it is minus. Plus and minus is minus, divided by 25. So 5 2s are 10, 5 5s are 25. That means d2y by dx square is equal to minus 2 by 5. This is the answer. This is the answer for d2y by dx square. Is that clear to all of you? So what was the value for dy by dx? It was minus 1. And what is the value for d2y by dx square? It is minus 2 by 5. So this is the final answer. So now we'll do the next question. So now we'll do the next question, that is question number 9. If capital F of x is equal to small f of x into phi of x, and f dash of x into phi dash of x is equal to a, here a is a constant, then you have to prove that capital F double dash divided by capital F is equal to small f double dash by small f plus phi double dash divided by phi plus 2a divided by f into phi. So here single dash, this single dash means first order derivative, and this double dash means second order derivative. Okay, so in this case you have to prove that capital F double dash divided by capital F. Actually you have to prove capital F double dash of x divided by capital F of x is equal to small f double dash of x divided by small f of x plus phi double dash of x divided by phi of x, phi double dash of x divided by phi of x plus 2a divided by 2 is constant, so 2a divided by f of x into phi of x. Actually we have to prove this relation. Okay, so let us write down given here. Here given is capital F of x is equal to small f of x into phi of x. Now we have to differentiate it both the sides with respect to x to get f dash of x. So differentiating both the sides with respect to x. Therefore, what do we get? Now what is the differentiation of f of x? Capital F dash of x is equal to, in this case you have to use UV rule because these are the two different functions of x. Let us use UV rule here. Now take the differentiation of the first function, that is f dash of x, keeping the second term as it is, phi of x, plus now keep the first term as it is, take the differentiation of the second function, that is it will be phi dash of x. So I think you have understood it. Okay, now again you have to take the differentiation to get f double dash of x. Again differentiating both the sides, with respect to x. So what do we get here now? So what is the differentiation of capital F dash of x? Capital F double dash of x is equal to, for the first function this is the product of two different functions. Here also you have to use UV rule. So take the differentiation of the first function, what is it? F double dash of x, keeping the second function as it is, phi of x, plus again keeping the first term as it is, take the differentiation of the second term. First term remains same, f dash of x, take the differentiation of the second term, it is phi double dash of x. I think you have understood it. Okay, oh sorry, this is phi dash of x, only phi dash of x, because you have to differentiate phi of x. So what is the differentiation of phi of x? It is phi dash x, not phi double dash of x, right? What is the differentiation of phi of x, keeping f dash of x as it is? It is phi dash of x, plus now similarly you have to differentiate the second term, which is also the product of two different functions. Here also you have to use UV rule. Now take the differentiation of the first function, keeping second term as it is, so it is f dash of x and phi dash of x remains as it is, plus next, now keeping the first term as it is, that is keeping the first term, that means f of x as it is, take the differentiation of the second term, what is it? It will be phi double dash of x. So I think you have understood it. Okay, so next, therefore this is capital F double dash of x is equal to, now write down the first term, small f double dash of x into phi of x, this is your first term, plus, so let us write down the last term here. What is the last term? F of x into phi double dash of x. Is that clear? And then you can add this second term and third term because these are similar terms. So both the terms have the same sign. You can add them. So what is it? Plus twice f dash of x into phi dash of x. So second term and third term are of similar types, so you can add them. Is that clear? So you can copy it. So now in the next step, in the question it is given that f dash of x into phi dash of x is equal to a. So wherever there is f dash of x into phi dash of x, you can write a. So this expression now becomes, therefore capital F double dash of x is equal to, this is small f double dash of x into phi of x, plus what is the second term? It is f of x into phi double dash of x plus 2 into a. That is, instead of f dash of x into phi dash of x, you can write a. किनभने क्वेशनमा हामीलाई दिएको छ f dash of x phi dash of x को सट्टामा के लेख्नु पर्छ? a लेख्नु पर्छ. Is it clear now? So now what is to be proved? Actually we have to prove capital F double dash of x divided by capital F of x. So how can you get capital F double dash of x divided by capital F of x? You have to divide these two equations, isn't it? So let us write it as number 2. So let us mark it as number 1. ठीक छ? तो त्यो चाहिँ number 2 भयो. So given चाहिँ भयो number 1. So how can you get capital F double dash by capital F? You have to divide 2 by 1. So right here, dividing 2 by 1. So dividing 2 by 1. So let's divide 2 by 1. So what do we get now here? So let's divide 2 by 1. So what do we get? So write down left hand side of number 2 in the numerator. That is capital F double dash of x divided by capital F of x, which is equal to next. Is equal to, what is there on the right hand side? You have to write down right hand side of number 2 in the numerator. That is small f double dash of x into phi of x plus f of x into phi double dash of x plus 2a. This whole divided by. In the denominator, what will you write? You have to write down right hand side of number 1. Right hand side of number 1. That is f of x into phi of x. F of x into phi of x. That is your right hand side of number 1. So I think you have understood it. Okay. Now let's simplify it further. So now what will you do in the next step? On the right hand side, you can separate the term. So left hand side here is, you have to keep it as it is. Left hand side, capital F double dash of x divided by capital F of x is equal to, now we can separate the term on the right hand side. So what do we get? First term, that is f double dash of x into phi of x divided by denominator. What is denominator? F of x into phi of x plus next small f of x into phi double dash of x divided by f of x into phi of x, right? Plus next one is, what is the next one? Third term. What is the third term here? 2a divided by, what is the denominator? It is f of x into phi of x. Is that clear to all of you? I think you have understood it. So you can copy it. Now let's simplify it further. So let us simplify it further now. So here you can cancel the similar terms from both numerator and denominator. Phi of x gets cancels. Here f of x. Okay. So next, what will you do now? Or capital F double dash of x divided by capital F of x is equal to, what are the remaining terms here? Small f double dash of x divided by small f of x plus here phi double dash of x divided by phi of x plus, what is the last term? That is 2a divided by f of x into phi of x. So I think you have understood it. Actually, we have to prove this result. The question says there is no x out there. So in the next step, don't write this x. You will get the required result, isn't it? अब हामी x नलेख्दा पनि हुन्छ, त्यो एउटा रुल जस्तै हो. त्यो क्यान्सल गरेको छ हैन, त्यो एउटा रुल जस्तै लेखेको हो. सो क्वेशनमा x छैन भने don't write x in the next step. Okay? So यो क्यान्सल गरेको छ हैन है, तर हामीले चाहिँ नलेखेको next step मा in order to prove the required relation. Okay? So therefore capital F double dash divided by capital F is equal to small f double dash divided by small f plus phi double dash divided by phi plus this is your 2a divided by f into phi. So we have proved the required result. Okay, so it is proved. So I think you have understood it. So you can copy it. So now we'll do the next question now. So now we'll do the next question, that is question number 10. If y is equal to e to the power ax into sine bx, then you have to prove that d2y by dx square minus 2a dy by dx plus within bracket a square plus b square bracket close into y is equal to 0. So from this given you have to prove this required relation. The पहिला हामी के निकाल्छौं dy by dx. So this question is very important. Okay, so here given is y is equal to e to the power ax into sin bx. Okay, so here x and y are the only variables here, so you have to take the differentiation, or you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? Therefore dy by dx is equal to, here you have to use UV rule or product rule. Now take the differentiation of the first function e to the power ax into a, keeping the second term as it is, sin bx, plus, now keeping the first term as it is, that is e to the power ax as it is, take the differentiation of the second function. What is the differentiation of sin bx with respect to x? It is cos bx into b. So I think you have understood it. Okay, let us simplify it. Or this is your dy by dx is equal to, a is written first, then write e to the power ax into sin bx, plus here b is written first, then e to the power ax into cos bx. Is it understood now? So instead of e to the power ax sin bx, we can write y, isn't it? किनभने क्वेशनमा दिएको छ instead of e to the power ax sin bx, y is given here. So or this is your dy by dx is equal to a into, what is the value for e to the power ax sin bx? It is y. So write y here plus b e to the power ax into cos bx. I think you have understood it. Now again you have to differentiate it, but before that take this term ay to the left hand side. Y को term लाई चाहिँ left side मा लगिहाल्नु. Or dy by dx minus ay is equal to b e to the power ax cos bx. So let us mark it as number 1. Okay, so why is it marked as number 1? Because we may use the value for b e to the power ax cos bx as what? Dy by dx minus ay. Now let's differentiate this number 1 with respect to x. Okay, so let's take the differentiation of number 1 on both the sides. So write down differentiating both the sides with respect to x again. Okay, so again you have to take the differentiation of both the sides with respect to x. So therefore what is the differentiation of dy by dx with respect to x? It is d2y by dx square, then minus a into dy by dx, right, is equal to, now on the right hand side you have to use UV rule. For e to the power ax cos bx you have to use UV rule. तर b is constant here. b लाई चाहिँ त्यतिकै राख्ने, b लाई केही गर्नु पर्दैन. b is kept as it is because b is constant. So b is taken as it is. b is taken as it is. Okay, so b is kept as it is. So now what is the differentiation of e to the power ax with respect to x? E to the power ax into a, right? So we have taken the differentiation of e to the power ax with respect to x. So it is e to the power x into a. Then write down cos bx. Then write down plus sign because we are using UV rule here. Now again b e to the power ax. b e to the power ax is kept as it is into, what is the differentiation of cos bx? Minus sin bx into b. It is, what is the differentiation of cos bx with respect to x? It is minus sin bx into b. Is that clear? So let's simplify it now. Or this is d2y by dx square minus a dy by dx, which is equal to, now here in this case let us write a first. a b e to the power ax into cos bx. Is that clear? So plus into minus is, you know that it is minus sign. So it is minus b square. b into b is b square. b into b is b square. Then write down e to the power ax into sine bx. Then minus b square. B into b is b square. Plus and minus. This plus and minus is minus. Plus and minus is minus. B into b is b square. Then write down e to the power ax into sine bx. So I think you have understood it. So now on the right hand side you can use the values from number 1 and given. Okay. So let us write it. Or d2y by dx square, d2y by dx square, then minus a dy by dx, minus a dy by dx is equal to, now from 1 we have got the value for b e to the power ax cos bx. Let us write it within bracket, because we can put the value for b e to the power ax cos bx from 1. So a is kept as it is, so within bracket let us put the value of this expression from 1. What is it? This is dy by dx minus ay, right? dy by dx minus ay. Is that clear? So we have put the value for b e to the power ax cos bx from 1. That is b e to the power ax cos bx is dy by dx minus ay. Is that clear? So then minus b square into, now what is e to the power ax sine bx from given? It is y. Is that clear? So you can copy it. So now we'll do the further simplification now. So or this is your d2y by dx square minus a dy by dx is equal to, multiply it. This is a dy by dx minus a into ay, a square y minus b square y. Is that clear? So next, let us simplify it. Let us take all the terms to the left hand side to make right hand side 0 in order to prove the given relation. So or d2y by dx square minus a dy by dx minus a dy by dx plus a square y plus b square y, which is equal to 0. So I think you have understood it. Okay. So let's simplify it. Or this is your d2y by dx square. What is minus a dy by dx minus a dy by dx? Minus, this is 2a dy by dx. This is minus a dy by dx minus a dy by dx. Similar expression, they are of same sign, you can add them. So it is minus 2a dy by dx. Plus, what is common here? Y is common. So within bracket, what do we get? A square plus b square, bracket closed, into what? Y, which is equal to 0. So here y is common here. So within bracket a square plus b square into y is equal to 0. So that is your final answer. So we have proved it. Is that clear to all of you? So we have proved the required result. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is 11 number 1. If y is equal to cosec x plus cot x, then you have to prove that d2y by dx square is equal to sin x whole divided by 1 minus cos x whole square. So from given you have to prove the value for the second order derivative, that is you have to prove d2y by dx square is equal to sin x divided by 1 minus cos x whole square. Okay. So here given is y is equal to cosec x plus cot x. Okay. So let us convert them into sin and cos. Or this is y is equal to, what is cosec x? You know that it is 1 by sin x plus, what is cot x? It is cos x by sin x. Is that clear to all of you? Cot x is cos x by sin x. So let us simplify it. So what's the LCM? Y is equal to, what's the LCM here? The LCM is sin x. In the numerator we have 1 plus cos x. Is that clear to all of you? Now let us take the differentiation. So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore this is your dy by dx is equal to, so here both the numerators and the denominators are variables here. So you have to use u by rule, u by v rule. You have to use u by v rule for its differentiation. So you know the quotient rule. This is also known as the quotient rule. So you know differentiation of u by v rule, isn't it? So keeping the denominator as it is, that is sin x, take the differentiation of the numerator. What is the differentiation of 1 with respect to x? 0, because it is constant. And for plus cos x, it is minus sin x. Then again you have to put minus sign out there. Now keep the numerator as it is. What is numerator? 1 plus cos x into. Now you have to take the differentiation of the denominator. What is the differentiation of the denominator? It is cos x. So I think you have understood it. Sin x differentiation is cos x. So whole divided by, in the denominator you have to write denominator whole square. That is your sin square x. So I think you have understood it. So let's simplify it again. So you can copy it. So अब हामी फेरि यसलाई सिम्प्लिफाई गर्दै जान्छौं. Or dy by dx is equal to, in the numerator, sin x into minus sin square x, then minus 1 into cos x minus cos x, right? Then minus into plus is minus cos x into cos x minus cos square x. So this whole divided by, so numerator is simplified. So whole divided by, this is denominator whole square, that was sin square x. This is your sin square x. So now we can simplify it further now. Or dy by dx is equal to, in the numerator, what is common there? Minus is taken common. So within bracket we have here sin square x plus cos square x divided by, this is your sin square x. So I think you have understood it. Okay. Now again, what is sin square x plus cos square x? You know that it is 1. Sin square x plus cos square x is always 1. That is dy by dx is equal to minus, within bracket, what is sin square x plus cos square x? That is 1. Then write down plus cos x whole divided by sin square x. Is that clear? So we have simplified the value of dy by dx. But again you have to differentiate it to prove d2y by dx square is equal to sin x whole divided by 1 minus cos x whole square. Okay. Now again you have to simplify it further. You can simplify it further, isn't it? So sin square x can be written in terms of cos square x, which is 1 minus cos square x. You know the formula of sin square x, which is equal to 1 minus cos square x. And then writing sin square x is equal to 1 minus cos square x, you have to simplify it. Okay. So or this is your dy by dx is equal to minus, within bracket, 1 plus cos x whole divided by, what is sin square x in terms of cos? It is 1 minus cos square x. Is it clear to all of you? Now again you have to simplify it to take its differentiation. So now, so how will you simplify it now? So what will you write down for 1 minus cos square x? What will you write for 1 minus cos square x? What is the formula again? So in this case you have to use the formula from algebra, that is a square minus b square. So what is a square minus b square in the denominator? So or dy by dx is equal to, numerator is kept as it is, minus, within bracket, 1 plus cos x whole divided by, what is a square minus b square? So actually it is 1 whole square minus cos x whole square. What is the formula? 1 plus cos x into 1 minus cos x. So here you can cancel, 1 plus cos x will be cancelled. Or this is your dy by dx is equal to minus 1 upon 1 minus cos x. So I think you have understood it. So we have got the value for dy by dx. Now again you have to differentiate both the sides with respect to x to prove this required result. Okay. So now in this case, so this numerator is constant, only the variable is denominator. Denominator ma matai variable cha bhane yo denominator hami mathi laन्छौं. So in this case don't use u by v rule because your numerator is constant, only the variable is in the denominator. So you can take this 1 minus cos x to the numerator, or dy by dx is equal to minus within bracket 1 minus cos x whole to the power minus 1. Now differentiating both the sides with respect to x. Differentiating both the sides with respect to x. So therefore d2y by dx square is equal to, now you have to take the differentiation of 1 minus cos x whole to the power minus 1. You can take it as x to the power n. Only the variable here is 1 minus cos x. You should take it as x. So this is x to the power n. So what is the differentiation of x to the power n? N into x to the power n minus 1. So here minus 1 comes in the front, minus into minus plus 1. What is x here? 1 minus cos x whole to the power minus 2. Now decrease the power by 1. That is n minus 1 should be there. So it is minus 1 minus 1. That is minus 2. Into, again you have to differentiate the term which is assumed as x. So in this case 1 minus cos x is assumed as x. So what is the differentiation of 1 minus cos x? It is, for 1 it is 0, and for cos x it is minus sin x. So minus into minus plus. This is your sin x. So I think you have understood it. Okay. So now in the next step, what is d2y by dx square is equal to? So therefore d2y by dx square is equal to, now this 1 into sin x is sin x divided by, now this 1 minus cos x whole to the power minus 2 can be simplified by taking it to the denominator. So if you take this term 1 minus cos x whole to the power minus 2 to the denominator, what does it become? It becomes 1 minus cos x whole square. So 1 minus cos x whole to the power minus 2 is actually 1 upon 1 minus cos x whole square. So we have proved the required result. Is that clear now? So it is proved. So you can copy it. So I think you have understood it. So this much is for today. त आज हामीले जति पनि प्रब्लमहरु गर्यौ त्यो सबै रिभिजन गर्नु बुझ्यो. So in the next class we will do more problems from this section, that is each question carries 5 marks. So this much is for today.